Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight you can grab your TI-Nspire and we will help you jumpstart your school year. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, we're joined by our two panelists, Sherry Abel and Jan Michener. Sherry is entering her 35th year in education. She has taught middle and high school math for the past 28 years, including Algebra 1, Geometry, Algebra 2, Pre-Calculus, and AP Stats. After spending several years as a state transformation coach, she's currently the district high school math specialist for Charleston County Schools. Her passions include helping other teachers see the power in having students explore mathematics concepts through the use of technology, as well as helping students make connections between math and the real world. Sherry, it's great to have you with us tonight.
Thanks, Mike. It's awesome to be here.
And Jan has been a mathematics teacher for over 35 years as well, teaching courses from Algebra 1 through Calculus 3. Jan is currently a pre-calculus and calculus instructor with Indiana Online. She received the Presidential Award for Excellence in Science and Mathematics Teaching, is an AP Calculus reader, and has been with the T-Cubed organization since 2003. Her passion is mentoring and training teachers on using technology as a tool to enhance learning. Jan, it's great to have you with us tonight.
Hi, Mike. Thanks. It's great to be here.
We're expecting a large crowd, so your audio is muted. Feel free to say questions to Sherry or Jan using the Q&A window on the right side of your screen. As a reminder, the session will be recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. And we hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Jan is going to discuss our agenda.
Okay, our agenda for tonight is, after our welcome and introductions, is Let's Party. And I'm sure you're going to really kind of wonder what that's about, but of course it will involve technology. And we will move on to everything about those functions, and then moving on then again to parallel lines. At the very end, we're going to have a little discussion about keeping it safe and other virtual tools for our classroom this year.
Thanks so much, Jan. And Sherry is going to discuss our expected outcomes.
Of course, we're going to have outcomes. We're hoping that by the end of this session that you will be more in tune with interpreting and analyzing graphs. We're going to look at really finding a line of best fit in multiple ways, looking at how to graph equations in different forms, and whether we're looking at a function or not. We're also going to touch on one of my favorite topics, which is domain and range, and geometry. We're going to give you a little plug for geometry because we know that so many of you think it's overlooked like I do, and it's a passion. We're going to look at some corresponding angles and alternate exterior angles, and we're going to jump right into safety of our technology for students this year.
Thanks so much, Sherry. And as I'm passing things over to Jan to get started, I just want to mention that if you do have your TI-Nspire, feel free to grab it. But it might be the best experience for you to have tonight to just kind of sit back and watch Sherry and Jan. Again, you'll get an email with the recording as well as all the documents that they're using tonight. So it just might be a better experience to just kind of sit back, relax, interact, and watch. Jan, it's all yours.
Okay, I hope I'm sharing my screen right now.
That's great.
So here we okay? Yep. All right, so here we go. The party for today. I always think about when I start school, what is the hook that I can experiment with or have that first day of school. So when my students walk out of the classroom, or maybe this year when they walk away from their computer, they can say to themselves, this is going to be a good class. So this little party is going to involve Twizzlers. Here's the scenario. You're having a party and serving Twizzlers. Several of your friends decide to have a Twizzler eating contest, and you decide to take part. Now, notice these Twizzlers are individually wrapped. This is for our safety this year, and you can find these Twizzlers like at the big box stores, probably like a Sam's Club or Costco or something like that. This is a linear function lab, and our materials are going to be, of course, the Twizzlers, some sort of a measurement tool, and I would probably guess that maybe a copy of a measurement tool if you're in a school where it would be a little bit safer for kids to be like taking a bite of a Twizzler and then placing it down on that piece of paper, and of course not sharing. Again, you could probably even take a ruler and, sanitize it, wipe it down, and they could use that as well. There are student handouts, and you will get those student handouts posted with this webinar, and you will also need an Nspire. The procedure is to start with a Twizzler of length 18 centimeters. Now, depending on what kind of bag you buy, you might have to take a bite or pinch it off to measure it down to 18 centimeters. You will then take a bite and measure how much of the Twizzler is remaining and record the data in the table. And then you repeat that for 4 more bites. So you can do pencil paper. You can have the students start with writing down their data in a table and graphing it, and then having them come up with a best fit line. If they don't have that skill set, we've got a solution to that with our TI-Nspire. So however much of that paper pencil you want to do, you are good to go. I put together just a little bit of a TI-Nspire activity to record our data in. On the next page, you will need to input your data. Now, just to review a bunch of these skills, to move to the next page, you can, as a teacher, click on the 1.2, or you can mouse over as a student on the handheld, or you can hit Control arrow right. This is where we would put our data. Now, the data needs to have a title up here, and I'll just put kind of like BB for right now. And then I would record my data here. And then over here, I would put, maybe these are links, so I would put LL. Okay? Now, to save time, I went ahead and collected some data. And I went ahead and labeled my first column bytes and the second column length. So we have to think about, how would we do this virtually? Well, you could pretend to be simulating this, this experiment as a teacher with your students. If you're doing a live presentation, you could have the students, maybe have it as part of, if they can, put it on the grocery list for mom to get and dad to get some Twizzlers, and have students do this themselves. Or again, you could just give them some data for students to input. Now, you could also have a student running your calculator if you want to pass the ball to them or remote to them for them to be able to use your teacher software. Or students might have their own that they could follow along if they have their own calculator or their own software that they've maybe done the 90-day trial or something like that. Lots of ways that you can input this.
Hey, Jan, let me cut in right there. Also, virtually, if you open a Google spreadsheet, a Google Sheets, you could have students who are giving you data if they are actually doing the Twizzler at home, and you could input their data there if you're collecting data like that, because you can copy paste straight from that Google Sheet right into your spreadsheet here in the TI-Nspire world.
Perfect. Thank you, Sherry. Okay, so now we're ready to graph this. So I like to graph using a list and spreadsheet. So I'm going to see if I already have, I put another sheet in here. On the next page, we're going to graph our data, and that was a list and spreadsheet. We're going to go to the data and statistics page, and we are going to be working with a movable line, a plot function, and regression. So on this page, I went ahead and had it set up for students, and I must have deleted it. So to add in a page, I'm going to hit Control, Doc, and I needed data and statistics. And there is my data just kind of all floating around there. So I'm going to come down here to the horizontal axis. This is a good time to think about or to talk about what's an independent variable and what's a dependent variable. If I click here, I have my bytes. And if I click over here, I have my links. Okay. How cool is that? The first time students see that, they just love seeing those little dots move all around. And so it's just kind of interesting to see. Now, I'm going to go to my menu. Well, first of all, before I go there, let's talk about, or let's maybe put some suggestions into the chat window. What kind of questions could you ask your students about this data? And I cannot see that right now.
I can. I'm monitoring that.
Okay.
Somebody said, do you see any trends in the data?
Mm-hmm. Trends, good. I would look at...
Is it increasing or decreasing? Do you see a pattern? Or will the byte links be the same as be the same for each group? So that's looking at comparing data.
Yeah. Yeah. So good questions. Some other questions I would think about would be, can you interpret the meaning of the x-intercepts? Can you interpret the
question also that was really great? Must this be discrete or continuous?
Perfect. A good time to bring in that discussion. What is discrete? What is continuous? And this is a great experiment to just, an activity to kind of drive that point home.
And somebody made a prediction as well. What will happen at 6 bytes based on your data?
Good. Good questions. Thanks. Okay, moving on to menu. Let's kind of look and see what we have here. When I'm looking at the menu, I'm going to focus in on Analyze for a little bit. Analyze, okay, we're going to add a movable line. Now, Sherry mentioned this the other day, and it kind of took me back a little bit. This is back to basically the spaghetti days. How many of you used pieces of spaghetti, gave them to students to move around to try and make their best fit line? I did that. I even put one on my calculator screen. I would make them small enough so students could put them on their calculator screen. So this is just kind of like our electronic piece of spaghetti. And how nice is that is it comes up with our equation of a best fit line here. So Sherry, thanks for reminding me of that. And right here, these little curlicues, I just want to maybe mention that when you see that symbol, I call it the roundabout, that's going to rotate your line. But if you go to the center, you get the plus sign, and that translates your line. So just kind of wanted to do that. Go back to menu again. And then we go to Analyze, and now we can remove that movable line. We're done with that. We're ready to move on. And the next thing I want to move on to would be still Analyze. Now I'm going to work with plot function. Now notice as soon as I put in plot function, it said F1 equals. This is where if we had the students come up with their best fit line, they would type this in here. So I'm going to go ahead and type one in, 3x plus 18. And I'm going to hit enter. And oh, look, my line is not even close to what it should be. And I do this on purpose to show students, hey, what needs to be adjusted in order to make this fit our data? It appears that my slope is going in the opposite direction of what I need. This one's a positive slope, this one's a negative slope. So let's just click on here and put in a negative and see if that is what fixes it, and it is. So make sure that you, show some mistakes and help students on what they look for to maybe adjust their answer to make it look like a little bit more accurate. And that way they're not running to you every time that there's something wrong with their calculator. They can start to fix those things themselves. All right, so this one, as you see, it's going to be stored in F1. And if I were to go to, let's add another page. If I were to add a graph, and if I arrow up, boom, there it is. Okay. So let's come back here. I'm still not done with this page. I want to go to Menu, Analyze, And let's go to regression. If I go to regression, notice I have linear. MX plus B is the form that we mathematicians enjoy. And notice it switched over to y equals. So this is my regression equation that the calculator came up with, and it is not stored in a function here. But it's nice to see that. Okay.
Could we talk about for just a second, Jan? This is a
Yep.
great question that I've been watching the chat for. If you look at that plus 17.76, someone said a great question to ask is, why isn't it 18? Because we know we started with 18. Why then does this come up with plus 17.76 and some other digits?
That would be a good discussion to have, with students. And, and I purposely did not have perfect data here so that would not come out to be perfect. I think sometimes we err in giving our students perfect data where it's always going to work out to be exactly what it should be. And this is real world data. This is data that's not perfect. These bytes are not the same every time. Okay. All right. We ready to move on here?
Mm-hmm.
All right. Now, one other thing before I go any further is, since we're on regression equations, I'm going to go back here to this listen spreadsheet. We can go to a cell over here, and we can certainly do our regression over here. It's not as fun. You don't see those points moving around. I can go to menu and statistics, stat calculation, perform my linear regression. And for my X list, I have to tell the calculator where to find it. That was bytes. My Y list is length. I'm going to store this linear regression. This is what I like about doing my linear regression here. I can store it in F2, and everything else I'm just going to leave blank and hit OK. And yes, I do want to overwrite whatever data I had there. So if I look, there is my equation. And if I go, let's advance over here.
The nice thing about that, Jan, as we're getting to your next screen, is somebody had asked about the correlation coefficient, would it show? And you notice that when Jan actually calculated it in the spreadsheet, you get your correlation coefficient. So that is one place where you will see that.
Yes, and I have to arrow down a little bit to get that. It does, right. The correlation coefficient does not show up on that data and statistics page. And it's not where I was working.
Right, and it will show up again if you actually do the same calculation on a calculate page, a calculator page. So those are the two places where you can actually see your correlation coefficient.
Okay, so here are my two equations that I had. Notice there's no check mark over here. You might be asking, why are these not being graphed? There's no check mark there. If I hit enter, it will graph. Okay. And when I'm in this page right here, I'm going to leave that one graph. I'm going to hit my tab key. Notice there's no F1 equal F2. So I hit my tab key just to remind you that that's how I can get my input line to come back. And I always like to talk about maybe you have a student who cannot, for as much as they try, be successful in solving for y. I'm going to hit the delete key one time. And notice all the options that come up. These are also where you can graph your inequalities, but I'm going to choose number 6, relation. This relation means that I can type in 2x plus 3y. Let's put equal to, I don't know, 2. And then when I hit enter, there's my equation. Okay. I will use this a lot if it's really hard to solve for y. Now, when I hit tab again, this sometimes gets frustrating to students if you don't remind them of this, that the calculator will stay in that relation mode until you switch it out. So to switch it out, I hit menu, graph, entry, edit. I want to go back to a function. Oh, did you see there on that screen there was also a relation option there? I would like to go back to relation and type in a quadratic. I'm going to do my negative x squared plus y equal, maybe negative 3. Let's see if I picked a good one. Yep. All right. Now, on this screen, what I would like to review is everything that we can do with analyzing these equations. I'm going to look at, first of all, something early on in the year that you might have to do is finding zeros, finding x-intercepts, just depending on your curriculum and if you're in Algebra 1 or Algebra 2. So let's review finding a zero or an x-intercept. Menu, analyze graph. It's pretty self-explanatory right there, is 0. Now, notice I have 3 functions right here. My calculator is not really sure which one I want to find the 0 of. It's asking for the graph. All I do is go over and I click on the one I want to find the 0 of, that pink graph. I have now my movable vertical line. It's asking for lower bound. I just need to place it to the left of the 0 and then slide over, and that's my upper bound. Now, these points get in the way, so I'm going to put my cursor on top of it, click and hold, and drag it. But here's something else I want to show you. On this point, especially in calculus, we need more than 2 places past the decimal. So in pre-calculus, I'm always telling my students I want 3 places past the decimal. I hover but do not click over that point and hit the plus sign. And then I get more digits appearing on that point. And that's a nice little feature to remind students about. Let's find our point of intersection. It's going to be very similar to what we just did. I'm going to hit Menu, Analyze Graph, and then I'm going to do Intersection. And again, I have 3 functions here. If I only have 2, I will not get this question down here. It's asking me what graphs do I want to find the intersection of. So I'm going to say, yes, I want that relation plot. That's my first graph. It's now asking me for the second graph. All righty. Now it's saying, what's my lower bound? Boom. What's my upper bound? And then the point appears as soon as I roll over it, but I always like to move it out of the way. In pre-calculus, in my class, I start early in the year talking about looking at functions and their graphs, and where is the graph increasing and decreasing. And in order to do that, students need to be able to figure out or to find a max or a min on my graph. What's the lowest point? What's the highest point? So again, analyze graph. And I'm looking for a minimum, in this one. Okay, again, which graph do I want to find the minimum of? Right there. It's the pink graph. And I'm going to lower bound. Again, that's all pretty much the same. Upper bound, there's my minimum. Of course, to find increasing and decreasing, we're going to have to find both a minimum and a maximum. So this one I could find maybe the increasing. All right, I would like to add a page. So I'm going to hit Control, Doc. We'll add a page, and I'm going to add a graphs page. This is for teachers who like to make their own graphs for their quizzes, activities. I'm going to do a little bit with this. I would like to graph, let's do a fraction. I like pretty fractions, so I'm going to hit Control Division to get that nice vertical fraction. And I have 1 over, I'm going to put x minus 2. And then I'm going to hit Enter. Okay, now, first of all, I always hide my equation. So I right-click on the equation, and I hide it. The next thing I like to do is to make my graph of my function pop a little bit. So I'm going to put my cursor on the graph, right-click, and I'm going to go all the way down to letter B as color, slide over to line color. And then I like to still make it dark, so I usually pick blue. And then I also like to change the width of that line. That is an attribute. So I click Attribute, and we've got some choices here. Right now my line weight is thin, so I'm going to change it to medium and then click off of that. So that kind of stands out a little bit. But I want to be very clear on where that vertical asymptote is. So I will hit Tab, and then I want to graph X equal. I will hit Delete one time, choose number 6 relation, and then just type in X equal my vertical asymptote of 2 and hit Enter. I'm okay with green. A lot of times I like my, for some reason I always use red, but I don't know, I'd have to probably research maybe are colorblind people okay with the mixture of blue and green? Can they tell the difference? Well, to make sure they can distinguish, I am going to right click and do attributes. And I'm going to change that vertical line to be dashed. So there is my asymptote. Okay. Now, like I said, I'm making this for a, maybe a quiz or a test. So I want to remind everybody that over here is a little camera. Remember, you can take a screenshot and screen capture what you just did. You click on Capture Page. And down here at the bottom, you can view it. And over here, you can see the image that I just did. Okay? And then you can just copy and paste that back into your Word document or whatever document you're working on. So don't forget that you can do screenshots to make your quizzes and activities and things like that. Now, one last thing I want to do is I sometimes see this number, this little tick mark is labeled as 1. I like to see tick marks labeled all the way across if I can. So move your cursor so it's right here on top of your axes and right click. And we're going to go to Attributes. And on this one, if I arrow down, the third one down, I have single tick labels are shown right now. If I arrow, whoops, I lost it. Let's go back to Attributes. And arrow left, multiple labels are there. Now, sometimes you won't get those multiple labels, and it did say to adjust your windows. And so if you need to do that, you click and hold your axes. Notice as soon as I moved a little bit, they went away. There's just not enough space on that screen. But there they're back, so you just kind of play with it. All right? The other thing you can do is up here on the right-hand corner, Document Preview. You can always change that to Computer if you want it to look a little bit cleaner without all the labels at the top. Okay, so that is an option to do a screen capture of the computer option. All right, that is all I'm doing with that Twizzler activity and that TNS file. I would like to switch over to something that I found in the math-inspired portion of education.ti.com. There are a lot of pre-made activities that have the TNS file already done, and they have nice documents to go with it as well. So this is one of those activities called Function or Not a Function. And again, it's a really nice feature of having a hands-on activity for the students to visualize that action consequence. As I move that vertical line, what's happening? Now, this first page, I'm not sure I would leave all of this on here. It just says on the next page, you will drag a point P left and right and count the number of times the vertical line intersects each graph. That's leading them a lot into what they're, maybe what I would be wanting them to observe. Maybe I would just say, start with this page and just say, take point P and slide it across these two graphs and tell me what you see. The top one is a function. The bottom one is not a function. All right, just kind of asking students to maybe discuss and discover and explore and not lead them into the fact of how many times does it cross through. See if they can come up with that. All righty. On the next page, if I Advance to the next page. Now I have tables. The left table is a function. The right table is not a function. I would ask my students, can you explain to me why the table on the right is not a function, but the table on the left is a function? Can you find, what is different about these? And again, hoping that they come up with, hey, I have two x values that are being used with two separate y values. So x is represented twice. I think a lot of times in Algebra 1, my students would say, just scan the x column and see if there's repeats. And so they may even look at that and come up with that conclusion. Here's a nice screen of multiple representation where you see at the bottom down here, you see the actual equation. We see the equation being graphed, and we see the table over here on the right side. And again, I can take that point and drag it, and hopefully after using those last two screens they are looking at, that vertical line is only crossing through that graph one time. And I'm not seeing any repeated x values over here. This has to be a function. Moving on to this parabola, again, the equation is down here, so they can get used to seeing what the equation looks like. To the right here is my table of values. I can click and drag that point along. Yes, that is a function. Here I'm looking at, down here, x equal to the absolute value of y. This looks really different. My absolute values in Algebra 1, when you first start, they're usually vertical. This one's on its side. And look what's happening. It is not a function because we have this vertical line crossing through twice. And if I look over here, -2 is matched up with both 1 and -1. 0 I have occurring at 3 and -3. So I'm seeing repeated x values. So I do not have a function. And again, with a circle, same thing here. Okay, not a function. And that is the last of it. Okay, now this is a TNS file, and the documents with that, you can find them on TI-Nspire, but you can also, they will be posted here as well, so you can get them easier from wherever Mike posts them at. Sherry, I think I'm ready for you to take over.
Yay, it's my turn. What?
Let me see if I can assign this to you.
Okay, so while you're doing that, we've had a couple of questions.
Okay.
One was, I have the Inspire, students don't, some might have an 84. Are there any online free calculators with the same functionality? I'm going to tell you that I taught without a class set of Inspires for a long time before I could get a hold of them, but I had my own software. I had my teacher software. And so I instructed my class using my teacher software because it was just important to me to be able to get across the conceptual understanding of the math, and I knew I could do that with Inspire. So whether you're using a virtual platform to deliver your instruction because you're not back face-to-face, or whether you are face-to-face, even if every student doesn't have a handheld, you can still drive your instruction using your teacher software and either have kids come to your whiteboard to drag things around, or virtually you can throw them a remote control of the calculator screen and have them drive the instruction that way. And one person also said, can you insert any text underneath the function table and state to the students whether the table is a function, the table? So that's a different environment, and I'm probably going to let Mike answer that question. Or I know Dennis Wilson is on this call. He can actually unmute himself and talk about that a little bit. That takes a little bit of programming in a way to get that to do on the table page. And I hope I'm not misspeaking on that, but if Dennis wants to chime in the chat box or unmute and chat and say, that would be great. Anytime.
I'm not sure if Dennis is actually able to unmute tonight. I think we have everyone muted, but I think you could write a when statement. So, when there's an intersection, it will display, one thing versus another.
Right. There's some programming that has to occur underneath that because of the page that you're using. to have that happen, and it is a win statement. And if you want more information on that, you can email one of us afterwards, and we will make sure you have it. So just to continue on with a party that Jan started, I'm going to take you through Domain and Range 2. This is out of the Algebra 2 section in Math-Inspired on the website. The interesting thing about it is, although it's listed under Algebra 2, I have pulled this one and used it in Algebra 1. There's also a Domain and Range activity built in Algebra 1, but this one just really, I don't know, this is the one I have a passion for. The interesting thing about Domain and Range is it's one of the most difficult things for students to kind of wrap their heads around. And it doesn't matter what we've done in the past, how we've tried to help it stand out, how we've tried to help them visualize it, but this document does a really great job. And just like with the document that Jan showed you, this comes with its own set of student worksheets that go with it that help them drag a point. What do you notice? What do you wonder about what's happening? And really hone in. So you notice that this is a set of discrete data, and if I grab point P and I move it along, you should see something happen. And you have to sit there and notice and wonder. So I noticed that every time I drag it, I get a blue asterisk or star that appears on the x-axis and a red one that appears on the y. And so I have to wonder, what is that? What's going on? But I also noticed down here that the ordered pair associated with point P is two different colors. The x value is blue and the y value is red. And so I can see now, wait a minute, this is at 4 and that, or -4, and that matches up, and that's at +4 and that matches up. Hey, wait, does that work for each one of those? Well, dang, it sure looks like it does. So they're beginning to see the notion that the x value of the ordered pair is highlighting the domain of the ordered pair, of the set of ordered pairs, and the y the same. So if you go on, look at this. This is a discrete, not a discrete, but a continuous set of data, but it has endpoints. So when I drag P around, and I've got to get rid of this so I can. So if I drag P, I can take it and show the domain and range, and that it's going to have an end value, that it's going to have an interval over which the domain exists and the range exists. And you can see that that continues on. This highlights what a step function is going to look like. So this one is always interesting because we can see that it's continuous for the x values or the domain and very discrete for the range. Same thing here, but notice that now we have an open circle versus something that continues, and what that's going to mean in the case of domain and range. So it goes on from there till we get to the point where we're now off of the particular drag and drop, and now you see a segment on here that has an open circle and a closed circle, and they're given very discrete sets of instructions to say, move this line segment to where it is closed on this value and open on this value. And they're going to have to move it around to determine, have they satisfied the constraints for domain and range. So it's a very powerful document that helps students really understand what domain and range is, and it does it in various ways. So that's just a huge, huge passion of mine. So now the geometry piece. The geometry piece, I can't say enough. Geometry gets overlooked, and I know people, I can hear you. Some are rolling your eyes, and I can actually hear that. And then I can hear other people, you know, kind of going, oh, God, geometry. I'll teach anything but geometry. And I was one of those until I had a department chair who forced me to teach it, who said, you need to teach it all so you can see the big picture. And I said, I'll teach it all, but anything but geometry, oh my gosh. But I taught geometry, and then I fell in love with geometry because I realized it wasn't the geometry that I learned when I was in high school. It was so much more than that, and it was an awesome subject. And then the more you dive into it, the more you know. So the things that I really wanted to show you tonight with respect to corresponding angles and alternate interior angles or alternate exterior angles, is the fact that often we go through these constructions because we have to. Oh, we have to construct parallel lines, given a line through a given point, blah, blah, blah. Here's a compass, here's a straight edge, now let's do it. And so people are like, okay, this kid's going, I got to do this stupid construction and there's no purpose for it. Well, let's think about this in different terms. What if it was more about, yes, you have to construct the parallel, but let's think of it in a way that we've not maybe thought of it before. What if I'm creating this parallel line because I'm very interested in one specific angle? So I'm going to go to measurement. I press menu first, measurement. I'm going to go to angle, and I'm going to measure this angle right here. And I can see that it is 75.1 degrees. And of course, we know if I right-click on that and change the attributes, I can make it look pretty if I want to and have it come out to a wonderful 75 degrees and make it appear like it's a nice number. Or I can make it appear as ugly as I want it to. I could drag it out as many decimal places as I chose. But we're going to leave it like that. What I want to do is I want to create a line that is parallel to line M through line B, but I want to move it along or translate it along this directed line segment from C to B. Now, I know that many times we teach translations using vectors, and often we jump right into the vector world. And I was one of those until I really learned about the directed line segment and how much fun that actually is and how much more meaning that brings to the mathematics than jumping right into vectors. So what we're going to do is we're going to go to menu, and I'm going to go to transformation, and I'm actually going to do this translation. I want to translate line M, in a directed line segment from here to here. Now, I've constructed this. I've translated line M to right here. So now this is really a copy of line M just moved along here. So now what I'm asking is, see this angle right here? If this is really line M just having been slid down this line, what is the measure of this angle? What does it have to be? And as if I'm waiting on you to answer, right? I'm really good at that. So I can hear all of you doing all of those mental calculations. So I'm going to measure it. It should be 75.1 degrees, and it is. So by using that directed line segment, we are showing how we're simply taking the original line, sliding it down, sliding it along this line, and we're simply moving this angle with it. It maintains its congruent state. So now what we've done is we've proved that corresponding angles are congruent based on a rigid motion. So that is something that I really, I know, somebody just put, sorry, that's not a proof by any mathematics that I've learned. No, it's not, but it is also looking at translation as a rigid motion to maintain congruency. And so it is a part of a step, because if you look at congruency, it's being able to move something in a rigid way through a rigid motion so that it matches one on top of the other. And I could do this. I could now translate this line onto this line, and those two angles are going to match up. So we're looking at another way of looking at proving corresponding angles are congruent. So this, if you're into looking at the way that illustrative mathematics builds out how they prove parallel lines cut by a transversal and how they look at proving corresponding angles are congruent, this is one of the ways they help students understand parallel lines, and it's through the translation of it through a directed line segment. So now if we look at the same outfit, we're starting again, but this time I want to measure that same angle. So if I grab that same point, so this time my angle measures a little bit different. But let's say I want to not translate the line. Maybe I want to rotate this line 180 degrees about point C. So if I do that, what's going to happen? I want you to think about if I take this line and I rotate it 180 degrees about point C, where do you think this angle is going to land? If we go to menu and transformation and we go to rotation, I'm going to choose what I rotate through what point and the number of degrees. So now I've taken line M and I've rotated it 180 degrees about point C. So where do you think this angle will have lined up or moved to? Thank you, Todd. Top left. He's screaming it at me. Top left, top left. So if we go to measurement and we go to angle, we're going to go here, and we find that our angle does indeed measure 73.7 degrees. I'm not saying that this is going to prove anything, but it does help students understand where these angles are going and how it might get transformed into that position. So if we look at this and we see that these two angles are congruent, then students can then see this as a linear pair, and they could figure out the measure of this angle. They can look at these two angles and know that vertical angles are congruent. They see that these are vertical angles, and now they can see that these two angles are congruent, and they're beginning to see a relationship between the alternate interior angles of parallel lines cut by a transversal. So this is just another way of looking at these types of angles without having to do, I'm not saying eliminate the original construction of parallel lines, because that's uber important, but this is just another way to show students through transformations of rigid motions how these angles are congruent. So that's just something that I think is very important to show students. It's a different way of looking at it. When students struggle, and I don't know why they struggle, but they do struggle with learning the types of angles and why these are congruent and what are they and how they look. So if we can help them see relationships in a different way, it helps them understand. So with that, that is my piece of the pie, Mike. And so I know you are so excited that I am going to actually throw the ball back in your lap. Are you excited, Mike?
I'm
Sherry,
excited.
Sherry, are you ready for your safe environment?
Yes.
Before you pass it back to Mike?
Too late. Jan, let me give you control.
What?
I think Jan had that extra piece for the safe environment that we wanted to do.
I don't think.
Yeah, sorry. I got all excited. Oh, yeah, I can do the safe environment. Do you have it on yours? Do I need to pop it back up on mine?
It needs to be on yours, Sherry. I don't have it.
Oh, okay. Awesome.
Okay.
Woohoo. Sorry about that. I got all excited.
You're not checking out yet.
Hey, did you throw it back? You did.
I did, yep.
All right, so you're seeing my screen again, right?
Yep.
Okay, so if we go to that, safety first, we cannot take any kind of whatever for this, credit for this. We saw this on Facebook because that's where you pick up your best ideas anyway. If you see this, this is great. And I know that there's tons of other ideas out there, but this is one way to keep your kids safe if you are face-to-face, if you're lucky enough to have them in class. You can either have the baggies or they can bring their own baggie. They simply slide it over the top of the handheld and pick it up. They do all of their button mashing through the plastic. So that is one great way to keep everybody safe. Another way to do it is if you are having them hold the actual handheld. TI has done this. They have tested this. As long as you don't go above a 90% grade in alcohol, it won't hurt the surface or the color of the Nspire. So you can take an alcohol pad and wipe it down, but you don't want to soak it. In other words, don't make it dripping wet and leave residue everywhere. You can also take 70% alcohol and put it in a bottle, a spray bottle, and spray a clean cloth with it lightly and then wipe it down really good as well. As long as you're not soaking it, you don't want it to be just dripping with it. And so there's a number of different ways. I see some of you, and I can't read the comments, but I see some of you are popping things into the comments. There's tons of ways to do this to make it a safe environment, but we wanted to bring that up. And then as far as the virtual world, and I mentioned it earlier, and I know Jan alluded to it as well, when you're looking at having to do virtual lessons, our Nspire software is so great because in most virtual platforms out there, whether you're using this one or whether you're using some sort of like Google Meets or you're using Zoom or something out there, you can draw students in by passing them the remote control and having them drive the calculator on your screen. That's student engagement. You can also annotate and have them annotate. There's a number of ways to get them other engagement in there by using Jamboards or using whiteboard.fi to give every kid a whiteboard so they can work their math out and you can see it all. So there are numerous ways to take this virtually and make it an awesome experience for your students, even though they may not have everything at home with them. Does that make sense? So see, I did it. I did it. Are you happy?
Yeah, there's a lot of suggestions in the chat room because the press and seal and wiping down in between classrooms or classes, if you have a classroom set. Some people say it's hard to find alcohol wipes, the Lysol wipes or whatever we're trying to find. So definitely spray bottle, put it on a little, paper towel or something like that and to wipe it down. They asked about with the navigator hats, if the bag was big enough. That was a quart-size freezer bag, and it works very nice in a gallon-size storage bag as well. And that way your navigator hats would fit in that as well. So that's the discussion I am seeing on that.
Right. And I'm also seeing, a couple of things. I know that Mike finally typed back. We're crossing our fingers. TI is listening, and I know that they're hard at work on getting teachers what we know that teachers need. So just keep your fingers crossed that great things are coming. Somebody did ask about a UV lamp, and I would have to defer to a scientist to know if that would work. There is software that is downloadable for students, but that is something that you would need to contact your ETC in your region for and ask them about how to do that. It is not yet compatible for a Chromebook, but I know that that is something that TI is also working on. But I never let that be a downfall for me. Again, I drive the instruction through mine. And so everything else is compatible on Chrome. Free. That is why I said you need to contact your ETC, and I'm sure that they will be able to help you out.
It looks like, I think we've gotten through all the suggestions on alcohol wipes. This one person suggested pouring alcohol in a bag and putting your paper towels in there and making your own little, or maybe washcloths or something. Paper towels can be thrown away, not washcloths. Making your own wipes if you can't find them. All righty? Okay.
So one thing I do want to share, we have a few people asking about some of those trial versions, maybe for the Nspire, or if you're an 84 user, where you can get that. And so if you're on our website, there's a Distance Learning Remotely Resources tab. If you go and click on that and then get support. and scroll down so you can get the free TI-Nspire software trial for teachers, the 80 formulator for teachers, and there's some other resources there as well. So please feel free to visit our website, education.ti.com.
Mike, can you go back to that slide? And what did it say about calculator loans right there?
So it says schools with economically disadvantaged students who do not have internet access at home can request to borrow TI graphing calculators while supplies last.
There you go. That's why I wanted to kind of see that.
So definitely check that out. The other thing I want to mention is that if you're enjoying this webinar format and you're not sure what might be up and coming, if you visit the Professional Development tab on our website, education.ti.com, and slide down to webinars. Here you can see that there's a split in the page. One is live webinars, that's all of our upcoming webinars, and the other is all of the webinars that we've done on demand. So if you go to live webinars, this is just a snippet of some of the upcoming webinars that we have up through the end of September at this point, and more are being added soon. And you can register for any and all of these, even if you're not sure if you're able to attend. By registering, you automatically get a follow-up email, whether you actually attend or you don't, with links to the documents, the certificate, and the recording. To receive a certificate of attendance, go and click the link that just appeared in the chat window. Also listed is a link for the documents that were used tonight by Sherry and Jan. And if you're missing these links or they're not working for you for some reason, again, just hang tight because you will get that follow-up email in a couple days. And that follow-up email should contain links to the certificate, the documents, and the recording as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. There were some great comments and questions that were offered in the chat and Q&A windows tonight. We really hope that you guys will continue the conversation on any of those major social media outlets. If you're in need of any additional post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or drop us an email, ti-cares@ti.com. We'd love to hear from you. Lastly, when you leave the webinar, a brief survey will automatically appear in your browser. That survey really guides us as we plan future online events. So we really hope you'll share your thoughts in the post-webinar survey. Big thanks to Sherry and Jan for everything that you shared tonight. We really appreciate it.
Hey, Mike, it was great to be here, and I wish everybody a good start to your school year and make the best of it.
Yeah, it's going to be a weird one, but I'm sure everybody's going to be awesome during it. We're going to make the most of it and have a great time.
Absolutely. Well, thanks so much for getting us ready for that. And again, thanks to everyone for joining us tonight. Please stay safe, and we'll see you next week. Have a great night.